Okay, we're going to do another type of integration, and this will be the last kind that we have to learn for the unit, but it's called trig substitutions. And some of this looks a lot like geometry, so I just want to talk to you about it. First of all, these are things that I hope you remember. This is SOHCAHTOA, so sine is opposite of hypotenuse, tangent is opposite over adjacent, cosine is adjacent over hypotenuse, and although we won't need cosine, we do need secant. And secant, you do flip that and make it hypotenuse over adjacent. So this is important. Also, just in case you needed to see the triangle, we are going to be looking at a triangle where our angle is T. Here's our angle, so opposite is across from it. Adjacent is the leg that's attached, that's not opposite, and the hypotenuse is across from the 90. So those things I think you know, but what is new are these things right here. So what will happen is you'll see problems where you have like square root of a squared minus x squared, or square root of a squared plus x squared. And in order to find the antiderivative of it, what you're going to have to do is substitute x to be one of these things. This looks like an awful lot like arc sine problems, but because the a squared is not first on this one right here, it can't be arc sine. Because there's a square root right here, it can't be arc tan. And so these are just different ones that we have to use, and we're going to use those substitutions. So these are some formulas you need to know. So here's our first example, and because I'm telling you on these to use a trig substitution, then I will help you to know that whenever we do these problems. But first of all, what you want to look at in the problem is figure out, okay, square root and what does it look like. So here we have a square root and an x squared and a 1. And so if we go back to what our formulas said, square root x squared plus 1 is this one. And so that means that x is going to be a sine of t. And the a is just going to be 1 because we've got a plus 1 right here. If that was a 4 or something different, then that would change. So here's what we know. We know that x is going to be tangent of t. Alright, after you figure out what x is, go ahead and find dx. Almost like finding du. We're doing a substitution. It just looks weird. So the derivative of tangent is secant squared. So instead of trying to look and see what you have in the problem to substitute it in, what you're going to do after you get those substitutions is you're going to take x and take dx and substitute it in for every x and dx in the problem. So we're going to rewrite this integral as the dx goes here, so we're going to write secant squared t. Alright, we know that x is tangent, so we're going to write tangent squared t. And then tangent squared t will go there as well, plus 1. And then we changed everything to dt now. Since all these are now in t's and there's no x's, this is dt. So at this point, you want to simplify and see what you have. Alright, what we know is that, I'll go ahead and write this again because I know that this is true. Alright, square root of tangent squared plus 1. Alright, I know that tangent squared of t plus 1 is secant squared of t. So this right here is, so the square root equals the square root of secant squared t. Well, that means that if I just want to go ahead and take the square root, I can. So we know that we're going to multiply this by secant of t because that's what that represents. Okay. Alright, go ahead and simplify. We can get rid of a secant. Now, anytime that you have sines and cosines in a problem, or tangents and secants like that right there, we do want to try to change things to secant and tangent if you can. But if you'll notice, see the tangent on the bottom is what's squared, and if I start changing like that to secant squared or something like that, I'm not able to like divide anything. And so this problem is an easier problem to solve if you will just change things to sines and cosines. Okay, I know that secant is 1 over cosine, so I'm going to go ahead and put a cosine on the bottom. I know that tangent is sine squared over cosine squared, and since it's on the bottom, I can just flip it up, and so I can multiply that by cosine squared over sine squared. And then I can simplify that to be cosine of t over sine squared of t. And now I could just do a u substitution to solve it. I'm going to let u be sine of t. du is going to be cosine of t. So this is the integral of u to the negative 2. Which if I add 1 would be negative 1 over u, or negative 1 over sine of t, plus c. Now, because we have made this substitution above, see, our answers are really supposed to be in x's, and we have answers in t's. So what we have to do next is we have to figure out how t and x are related in order to substitute back in what this equation represents. Okay, so I'm going to go back up here, and you could do this at the beginning of the problem if you want, or you can do it at the end. It doesn't matter. Here's our right triangle. Here's where my angle T is. Okay, what I just did up here is I said that x was tangent of T. Well, here's T, and the tangent of T is opposite of her hypotenuse. Well, if x represents the opposite of her hypotenuse, that means that this is x and this is 1. And if you solve by the Pythagorean theorem, you will get that the hypotenuse is x squared plus 1, square root of that, which you will notice is what we made that substitution with. That will always happen, that that substitution we make will be somewhere on that triangle. Alright, so how that relates to our answer, we've got negative 1 over sine of t. I want to figure out what sine of the angle is so that I can substitute it into that formula. So sine is opposite over hypotenuse, so sine of t is x over square root of x squared plus 1. And so this is the same as, and I'm going to flip it, negative square root x squared plus 1 over x plus c. And then that's our answer. So we have to start off by figuring out the trig substitution to let it represent. Substitute in what everything is that we know, simplify, figure out what method we're going to use to solve it. When we get our answer, we have to go back and change it to x's based on the triangle that we're going to make. Here's the second example that we're going to do. If I look at these trig substitutions, it says square root of 1 minus x squared. So the one that looks the closest would be this first one. So that means that I'm going to let x be a sine of t. A again here is just 1. So I know that x is going to be sine of t. That means that dx is going to be cosine of t. If you want to go ahead and make the triangle, you can, or you can wait till the end. T is always down here. I know that x is sine of t. Sine is opposite over hypotenuse, and so that's x over 1, so I know that this is x and this is 1. If I solve this using the Pythagorean theorem, it would be the square root of 1 minus x squared. And so there's my triangle. I won't need that till the end of the problem. So now I substitute everything that I know for x and dx and for x and dx here. So I have integral square root 1 minus, substitute sine squared here. Dx is cosine. And now we're all in t's. This one comes out nicely right here because this is 1 minus sine squared, I know is cosine squared. The square root of cosine squared is cosine. So this is the integral of cosine of t times cosine of t. Alright, so I know that that's cosine squared of t. And now we're down to solving problems using even powers. And we learned that we needed to change that to that double half angle formula, which is this formula. All that's over 2, but I'm just going to go ahead and separate it and put them each over 2 so that I can solve it separately. I know that this will be 1/2 t. Okay, the antiderivative of cosine is sine, and our u would be 2, du would be or u would be 2t, du would be 2, so there'll have to be another 2 here. So we've got 1/4 sine of 2t. Now, interestingly enough, there is one other thing that we have to do here before we're going to substitute in what we have, and it is to change this to another formula. Lots of formulas here with sines and cosines, and it is sine of t cosine of t. The reason that is helpful is because we're trying now to substitute in what sine and cosine are based on this triangle, and because it said sine of 2t, I was not able to do that because our angle is t. So now we're going to come and let's figure out what sine is. We already know that sine was x, so I'm going to go ahead and let that be x. Cosine is adjacent over hypotenuse, so that's going to be the square root part of it. Okay, and then we're back to, okay, what is t actually? Well, t is an angle, and so easiest thing to do there is maybe to solve this part right here, or think about it whichever way I want to, but t is actually arc sine of x, because t is the angle that when I take the sine of it, I get x. So t is going to represent arc sine of x, and then that is our answer.